So how to do some descriptive statistics in R. So we are starting with a fresh new markup here, and we'll insert some code like this. We're going to work with the empty cars, which we already used previously. The empty cars has a range of variables, data coming from motor cars magazines, and it's some basic data on the cars. So for example, let's start with some measures of central tendency. So some measures of central tendency. And we might start here with the arithmetic mean, which is the most common one. And in R, the arithmetic mean is invoked with mean. So for example, if you want to know the mean of something in empty cars, so for example, empty cars, and we want to have the mean for the horsepowers, the HP, and we get the mean for the horsepower, so 146.7. Now, if you want to do this across several times, or across different measures of central tendency of different descriptive statistics, of course it would be convenient to extract the horsepower vector out of the table. So we might create a new object called HP and assign it the values of empty cars $HP, like this. So then this command becomes a little bit more shorter. Mean of HP, and we run this and we get the same number. Now for other measures of central tendency, geometric mean, for example, for the HP, which should be smaller, and it is. And then we have the harmonic mean, again for the HP, and is the smallest of ones. So horsepower is a slightly right-skewed variable in our case. So if I do the median for the HP, it's also smaller than the mean. So that's a few of the measures of central tendency. Now, if you want to do central tendency across a range of variables within a data frame, so for example, for all of the variables in empty cars, what you can do is you can use the sapply function. So the sapply on empty cars, and I want the mean, right? And if I run it, it will compute the mean of all numeric variables in the data set. As you can see, the name was skipped here. And we can then do a similar thing for the measures of dispersion. Measures of dispersion. So for measures of dispersion, the range for HP, for example, the range will actually not return the value of the range, but it will return the minimum and maximum. So if you are interested in both, you just type range. If you're just interested in the mean, you just say min, mean, and it will just return the 52. The max will return 355. The classical dispersion measures would then also be the variance for the HP, and the standard deviation of the HP, like this. Now, of course, if you want to have this across all variables, again, you can use sapply. Empty cars and SD and you will get the standard deviations for all the variables. Another very useful descriptive statistics is also the quantiles. Quartiles, deciles, and so on. So for quartiles, so you always invoke this by calling quantiles quantile. So you are calling quantile for HP, and then you have to provide the probs. And for example, if you want the first and third quartile, as for probs, what you can do is you can combine 0.25, so 25% probability, and 0.75 for the 75% probability. And what you will get is the first and the third quartile for the horsepowers of a car. Now, if you want the deciles, again, it's quantiles for the HP, and again, props, and then you have C. Now, of course, now what I could do is I can simply type 0.1, 0.2, and so on, but I can also shorthand this a little bit. So if I do a C, and then if I write now in R, for example, if I write 1 to 9, now what this will do is it will return all the integers between 1 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I need probabilities, so this is not very good. And well, the easy way for doing this is just say like, okay, so I want to combine 1 to 9 and then divide it by 10 like this. And basically, if I run this, it will return the deciles. Now, of course, in quantiles, I can invoke other quantiles as well. If I don't want to do this descriptive statistics by descriptive statistics, but table descriptive statistics for a whole data frame, what I can do is I can use a function called summary of empty cars, not my cars, no, empty cars. Empty cars like this, and I get a table of descriptive statistics. So I get numbers minimum first, so for example in horsepowers you will recognize the minimum, which we got from range, the first quartile that we got earlier, the median you've seen, the mean you've seen, third quartile, and the max. So it will return these numbers. And this one, so the summary is also part of the base package. Now, a very neat, so the other ways of table descriptive statistics are actually found in different packages. One neat package to use in social sciences, it was written for psychology, but it's very useful in other social sciences as well, is the psych package. You can find it here. If you go to packages, you have the psych package. It's mostly procedures, so psychological, psychometric, and descriptive statistics and personality research. But as I said, it's very useful in other sciences as well. Now, in this package, what you have included is a so-called describe function. Describe is actually a very neat set of descriptive statistics. So if we run describe empty cars, if we run this, we get a very nice table where you find so the number of observations, then you have the mean, you have the standard deviation, median, you have the trimmed mean, were actually the outliers, so the extreme values are trimmed away. You have the maximum, minimum, skewness, kurtosis, range, and the standard error for the mean. So it's a very nice collection of descriptive statistics, very useful in practical applications. So this was a very short introduction on how to do descriptive statistics in R. Thank you for your attention.